Hello students. So in the previous few videos we have seen how to draw problems or how to solve the problems of dip and strike, and then we have studied for the borehole problems also. The third set of problems which we will be studying are thickness of strata problems. This thickness of strata problems are solved in order to understand what is the thickness, what is the depth, and in which direction they are dipping. Okay, so let us understand first the concept of what exactly means by the thickness of strata problem, or what are the terminologies which are involved in it. So if you observe this, there is a ground here, this is the line of ground, and if I say okay, this is the ground, we have a ground here. Okay, then this is the strata which is dipping. This line which is observed here is a line, or we can say a strata or a bed which is dipping in this direction. That dipping is calculated based upon the d. The diet is calculated based upon the d. And on a ground, whatever comes, that distance we call it as w, or we say width of it. We can say width of it. Then there are next terminology which is again important, is if I drop a line from the ground, if I drop a line from the ground and it touches the one of the bottom bed, if it touches the one of the bottom bed, this distance is called as VT, that's called as vertical thickness. I'd say vertical thickness, called as vertical thickness. And the horizontal distance, or from this bed to this bed, or the top end of the bed to the bottom of the bed, is called as TT. This is nothing but true, sorry, it's called as true thickness, called as true thickness. Okay, so these problems can be either solved by the graphical way or by the mathematical way. So if you want to find out the true thickness and vertical thickness, then there is a formula which talks about sin d into w will give the true thickness, that is nothing but tt, and tan d into w, which will give you the vt, which will give you the vt part of it. So if you have either the dip direction and width, you can find out easily tt. Same way you can find out the vt also. Okay, so with this note we'll start working on our problem. So let us take the first problem. Let us see the problem. At a dam site, a bed of a sandstone is exposed on the horizontal ground. It dips 35 degrees eastward and the width of the outcrop is 240 meters. Determine the true thickness, determine true thickness and determine the vertical thickness. That is nothing but TT and VT we have to calculate. TT and VT we have to calculate. So let us see the problem. Imagine this is our, again, first and the foremost is we have to draw the ground levels. We have to draw the ground levels. Okay, that is the most important task. Second, I have a width of the outcrop, that is 240 meters. I'll take a suitable scale. Okay, I'll say 1 centimeter scale here. I'll write down 1 centimeter is equals to 100 meters. I'll write down I'll take that as a scale, and I'll draw first the width, that is 240 meters. I'll say 240 meter is my width. The second most part, I completed this part. Now we completed this part. Now moving on to the next part, we'll draw a dip direction, that is 35 degrees. How we'll draw? We'll measure from this horizontal ground, we'll measure the distance. Okay, and we'll draw a 35-degree line over here. Then once I draw this, again at this point, either I can draw 35 degrees, or I can simply shift this line parallelly using the ruler scale. Parallelly I can shift this line using the ruler scale. Okay, and I'll draw this line. Okay, so this also will become the 35 degrees eastwards. So again, simplest way, you know, this is our north direction, this is north, this is south, this is east, and this will be our west. So if they are moving in this direction or in this direction, I'll say towards the east direction will be drawing it. Towards the east will be drawing it. Okay. So once you complete this, the given data is over. So they have given 35 degrees eastward, they have given 240 meters. This part is over. Now, based upon only this data, we have to find out TT and VT. How will do? I'll draw a line or which is will be perpendicular to the baseline. From this corner I'll drop a line and I'll measure this distance. I'll measure this distance. This distance will give me the VT, that is vertical thickness. That will be vertical thickness. Same way I'll drop another line which is again perpendicular to both of these lines as they are parallel. I'll be drawing this, and once I draw this I'll get a TT distance. So I'll measure this distance from this corner till this corner. I'll measure the distance, I'll get TT out of it. Okay, the same problem can be solved. Okay, I missed it. Here the vertical thickness VT is 168.05 centimeters and TT is 137.6 centimeters. Okay, so this is the answer for the TT and the VT. Same way you can calculate using the formula also. So they have given a D value, they have given a W value. So just put this in an equation, you will get answers. Okay, so almost both the things are similar to it. Both the answers are similar to it. Okay, so you are very close and accurate in the case of answer. So these are the very simple problems which can be studied or which can be solved. Similar way, we have given so many problems which based in different domain, like we have a TT-VT problems again. Will give you the other data and will tell it to solve. So we'll solve all these problems here in a brief. Mathematically probably I will not solve. Mathematically you can easily solve it. I'll just draw these problems graphically for the better understanding. Okay, so the first and foremost task is to draw the horizontal line. So I'll say coal bed is exposed on the horizontal ground. It dips 30 degrees eastwards and the width of the outcrop is 360 meters. So again they have given us the width and they have given the dip angle. So first task I'll draw, that is 360 meters or 3.6 centimeters I will draw. Then again it is in the, I'll take scale as here, 1 centimeter is equals to 100 meters, and I'll say this is our north line, this is east, this is west, this is south. Okay, then I'll drop a 30 degrees. Now it will be dipping in this direction, right? So I'll drop a line here. Okay, I'll say this is 30. I'll drop one line here. This is 30, and if I measure the distance, okay, if I measure the distance from here to here, I'll get what? I'll get a VD here. I'll get VD. Same way, if I draw a line which is again perpendicular to both these lines, okay, again perpendicular to both these lines, I'll get the value of TT also. Okay, I think that line has disappeared. Okay, they'll get the distance of TT also. Okay, this is how the second problem can be solved. Same way, let us see. You measure this, answers are already given. Okay, the answers are already given for the better calculation part of it. Now let us move on to the next problem, that is problem number 3. A bed of limestone is exposed on the horizontal tunnel. Its width is 200 meters and dips 35 degrees eastward. Determine TT and the VT. The same thing is there. Again I'll drop a line, that is my ground line. Okay, then I'll measure the distance as 200 meters, that is nothing but 2 centimeters. Then again I'll measure, again it is towards the east line only, eastwards only. So I'll just drop a lines. I'm measuring here as 25 degrees. Then I'll drop a line here. Okay, and I'll measure this distance, this to this distance. I'll get VT. Then I'll measure this distance parallelly, perpendicularly. I'll get TT also. The same way you can put it in the equation, you will get the answers for it. You will get the answers for it. Okay, now let us see the next problems. So here again, the coal bed, the problem number 4, the coal bed is exposed on the level ground. It dips northward. They said it dips northward on the top side they are given. Okay, so for understanding, you can draw the image in a similar way as well, or you can draw it in a reverse direction. We'll say towards the north direction. Width of the outcrop is 180 meters. Now here the problem changes. A borehole sinks from its upper bedding plane meets the lower bedding plane at 105 meters. So what this is? What is this? I just drop a explanatory figure here. Okay, imagine what they say. They say there is a horizontal ground and there is a width of the outcrop. Okay, width of the outcrop is given. So then, towards the northward, you can draw it on the top side. Okay, I'll just for your understanding, I'm drawing it here. Okay, so here, what they say, a borehole is saying from its upper bedding plane. So this can be your upper bedding plane and meets the lower bedding plane. So the from here this point the is major the borehole is sunk. So from here till here it meets the bottom bedding plane, and that distance is nothing but 105 meters. This will be your VT, that is vertical thickness they are given, but not directly they said vertical thickness. They said in a very tricky manner that they said the borehole is sink from the upper bedding plane meets the lower bedding plane at 105 meters. So that is nothing but your VT. Determine the true thickness and the amount of inclination. So here TT also we have to find out. We have to find out the D also. Okay, so if you go with the formula again, it's very easy task which you can perform very easily. Okay, so I think I don't feel that need to be solved, but the graphically I'll surely draw it. So now I'll say this is my bedding plane, irrespective of much not thinking much about the north direction, you can towards take east or west. Okay, so they said there is a width of the outcrop that is 105 180 meters, means 1.8 meters centimeters, 108 meters. And they say a borehole is sunk from the top to bottom, that is that from this distance I will be taking it towards the east line. So I'll say okay, second, from this point till this point I'll say just this point to this point is my VT, which is 105 meters. Okay, now once I get a VT, what I'll draw is I'll draw a line which joins from this corner and touches the bottom part. This I'll join first and extend it. Now you got the lower bedding plane. You got the lower bedding plane. Parallelly, you can draw the upper bedding plane also. Now if you measure this distance, then you will get TT value, and if you measure this angle, you will get the D value as well. Okay, so this is how this problem number 4 can be solved. Okay, so you can go further. You can take formula sin D into W. Okay, this is your for TT. Okay, now if you take it, the sin D is not given, but TT this cannot be used directly. Before that we need to solve it for VT also. Tan D into W, tan d into W. Vt is given, that is 105. Okay, then this need to be calculated. Width is given, that is 180 meters. So 105 divided by 180, and that is tan inverse of, okay, this will give you the value of d. This will give the value of d to you. Okay, so you can solve this and you get the values for it, okay. So same way, once you get the d, you can input here sin d value. Okay, sin d value you can mention it here from this equation, and already we know the w value, you can easily get the tt value as well. Okay, so this is how you can solve the problem number 4. Let us move on to the problem number 5. Westernly dipping limestone has its vertical thickness. Now here they are given directly. They said the vertical thickness is 130 meters. Okay, and width here they said westernly. Now till now we were drawing eastwards, this is westwards, and the width of the outcrop is 240 meters. Determine its true thickness and amount of dip. Similar like a previous problem we have to do. Okay, so I'll just explain here. So I'll draw uh, the horizontal ground. I'll draw horizontal ground. Okay, then they said it dipping westwards, so I should draw towards this line. Okay, but before that I will mark a width, that is 240 meters. Then I'll drop a vt. I'll drop a vt, that is vertical thickness 130 meters. Then I'll join this part. i'll, I'll join this part. Okay, and downwards I'll extend. Same way, parallelly I'll draw a line here. We already know vt. This distance if you measure, then you will get tt also. If you measure this angle, you will get d also. Same way with the formula also you can solve these problems. Okay, now moving on to the next problems. These are the last problems. Okay, so on a horizontal tunnel, a bed of a sandstone dips 30 degrees eastwards and its true thickness is 200 meters. So here now they give true thickness. Okay, they are not given a vertical thickness. They said now it's a true thickness. So how will we drawing it? Okay, so the sandstone bed dips at eastwards and the true thickness is 200 meter. Determine its vertical thickness and the width outcrop. So what I will do is, I'll first, as usual I'll draw a ground line. Okay, then the true thickness is being given. Okay, I'll just say it is dipping eastwards, so this direction it is dipping. I'll just mark one point. Other point I don't know because it is width. Other point I don't know, it is width. I'll drop first. I'll hold one point, and here I'll draw a true thickness. I'll draw true thickness, or I'll say first I'll draw a 30 degrees dip. 30 degrees dip I'll draw. So I'll measure from this corner. I'll measure from here. Okay, 30 degrees, and I'll draw a line. I'll draw a line here. Okay, this is nothing but a 30-degree dip. Now I know the true thickness. Perpendicularly, I'll extend one line. Perpendicularly, I'll extend this line are 2 centimeters, whose distance is 200 meters. Then parallelly, this corner also I'll draw one more line. Okay, parallelly I'll draw this corner also one more line. This I got one line whose width can be measured. Okay, so this width can be measured on the ground here. Okay, same way I'll drop a perpendicular to the ground. Okay, and this distance if I measure, I'll get vt as well. Vt as well. So now you can use the tt formula here. Okay, sin d into W. Okay, so here TT is given, the TT value is 200 sine D sine of 30 into W. So now you can solve it. First convert the value of 2 sine value, okay, then calculate for the W, sine 30 you convert, then measure the W, and use this inputs for the VT calculation. Use this input for the VT calculation. Okay, same way now let us see the seventh problem as well. Okay, this is the last problem for this set. At a brick site, a sill is exposed on a level ground who dips 40 degrees, this 40 degrees northward, and its true thickness is 180 meters. Same way we have to solve this problem. First I'll draw a ground line. Okay, I'll mark one point myself randomly, and here I'll measure 40 degrees. I'll measure 40 degrees. Okay, so this is my 40 degree D value. Then I know TT 180 meters. I'll just extend it here. TT 180 meters, and then parallel to this line I'll draw one more line. Parallel to this line I'll draw one more line, and this distance will give you the width, while this distance, I draw it properly, this distance will give me PT as well. Okay, so this is how we have to solve all these problems. These problems will come for 5 to 10 marks in exam. Okay, so you can continue solving these problems, complete in your journal. You can solve them either if you have journal sheets, or else you can solve it in the books as well, but keep the records and be ready. So here I thank everyone for your patient listening. Solve these problems. If you have any doubts, you can surely contact me over here, and if you want to download these problems, you can visit my link to get the problems here. Okay, already problems are there, but still if you want you can visit it here. Okay, so I thank everyone for patiently listening. Thank you. Also subscribe to my channel for more such videos.